Hello everyone. For this tutorial video, I'd like to give a proof of the mean value theorem, starting with a theorem that is a prerequisite to it, which is called Rolle's theorem. If we have a function that is continuous and differentiable from point A to point B, and function of A is exactly equal to function of B, then we can prove that there is a critical point between A and B by first assuming that there is some value D in between A and B so that function of D is greater than function of A. And we saw the extreme value theorem earlier, which holds for continuous functions, which is what we are using in Rolle's theorem as well. So we know the function will have a maximum somewhere between A and B by this theorem. And because we are given function of A equals function of B, and function of D is greater than function of A, we know that the maximum will have to occur at a point C between A and B. Because C is in between A and B, this means that C is a relative maximum of the function, and we know that relative maximums have a derivative of 0. Or in conclusion, the function of point C between function of point A and function of point B must be a critical point. We next see if we assume that the derivative of the critical point is function of B minus function of A divided by B minus A. It follows that function of B minus function of A equals the derivative at point C times point B minus point A. And we can see graphically this is true too, because the tangent line at the critical point has the same exact slope as the line cutting through points A and B, which we call the secant line, which comes from Latin secare, to cut. So it literally cuts through points A and B. An example problem of the mean value theorem is this function over the interval from -1 to 2. We first compute the derivative, then plug in the formula for the derivative at the extreme point C. We set these equal to each other and solve for values of C. Because we cannot factor this easily, we use the quadratic formula, and we get only one C value on the interval specified. In conclusion, the mean value is at that specific C point. One last thing we can see about the mean value theorem is that, because we know the derivative at the critical point equals 0, it is reasonable to state that function 2 minus function 1 equals 0, and function 2 equals function 1. Now that we have figured out how to apply the mean value theorem in some cases, we can finally discuss real-life applications of derivatives, such as optimization problems, or finding the absolute minimum and maximum of different rates of change related to one variable. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.